All right, let's look at evaluating reference angles. All right, so we can define ratios in terms of x and y coordinates on the plane. This is, I believe, in your notes. Yep. Want you to write down a few things. Number one, that x is the adjacent side, y is the opposite, and r is the square root of x squared plus y squared, which is the hypotenuse. So add the information that is next to the asterisk in your notes. When we are graphed on the coordinate plane, if you can just add this, because this part here will be important when we're graphing. Right? So right now we're not holding our radius steady, right? It's just based off of whatever the adjacent and opposite sides are. But when we get to graphing, we're going to hold the radius steady at 1. If we hold the radius steady at 1, the x-coordinate is going to be cosine, the value for cosine, and the y-coordinate is going to be the ratio for sine. Right? And that's because you'd be dividing by 1. Right? And since x is adjacent, right, x divided by 1 is just going to be x. Since y is opposite, y divided by 1 would just be y. So just a little preview of what we'll look at when we're getting into graphing. But let's head back to evaluating for a little while. So theta here is an angle in the plane, and we know that we need to create our reference triangle. We go from, I'll actually draw this again, we go from our point straight down or straight up, depending on if we're above or below the x-axis, to the x-axis. That forms a right angle. Theta is always next to the origin. So this here is the principal angle. And since it's more than 90 degrees, we're not going to be able to evaluate that one. But this right here, we'll just we'll just call it angle B. All right, so angle B here is the reference angle, and we use that to evaluate our principal angle. All right, a review here, just a quickie review of our 6 trig ratios. No one better miss this. Sine theta is y, which is the opposite, over r, which is the hypotenuse. Cosine theta is x, which is the adjacent, over r, which is the hypotenuse. Tangent theta is y, which is the opposite, over x, which is the adjacent. Cosecant theta is r, which is the hypotenuse, over y, which is the opposite. Secant theta is r, which is the hypotenuse, over x, which is the adjacent. And cotangent theta is x, which is the adjacent side, over y, which is the opposite. All right? And here we are going, the value we get for theta will be exactly the same as our the ratio we would get for the reference angle. All right, so that's how we can use a reference angle to evaluate a principal angle. So sine B is also going to be the exact same values, and cosecant B would be the same as r over y, and cosine B, we'll evaluate our reference angle, we would get the same thing, x over r, and secant theta, we would get the exact same thing if we evaluate angle B, the reference angle. And we get the exact same thing for tangent theta as the tangent B, and the same thing for cotangent B as cotangent theta. And that's because we're going to take into account the signs. And the signs of in our different quadrants is what's going to make sure that we have the right ratio for the principal angle using the reference angle. Okay? Oops, we have this page twice for some reason. Sometimes they just duplicate themselves. There we go. All right, and this is all possible. So we're able to evaluate angles for certain angle measures, right? And it is whenever the reference triangle that angle there, that is along the origin, right, has the vertex at the origin, whenever it is whenever that angle is 45 degrees, 30 degrees, or 60 degrees. So we can evaluate an angle, any angle at all, if it is a multiple of 45, a multiple of 30, or a multiple of 60, right? No matter how big or small, right, we can evaluate it using the special right triangles. Right, as a little reminder, for the 45, 45, 90, which is also can be known as the pi fourths, pi halves, right, the legs are 1 and the hypotenuse is the square root of 2. For the 30, 60, 90, which we can think of as pi 6, pi thirds, pi halves, the side that's opposite the 30 degree, or the pi 6 in radians angle, is 1. The side that is opposite the 60 degree, or the pi thirds in radians, is the square root of 3. And the hypotenuse, which is always opposite the right angle, is going to be 2. Twice the short leg. All right, so I'm going to do 6 here. I'm going to do 1 in every quadrant. I've got every trig ratio covered, so we're not going to do all of them. I'm going to do 1 trig ratio per problem here. I'll do 1 trig ratio, and I'm going to switch around the quadrants. I'll make sure I've covered all 6 trig ratios in all 4 quadrants, plus a few little challenge problems. These are your steps. All right. When I'm notice that there are 4 steps. Oh, look at that. So I'm evaluating you on the 4 steps. Right. If you're missing a step, you don't get that point. All right, so step number 1, and this is going to be true for any of our angles, whether we are evaluating them in degrees or in radians. All right, so we want to evaluate sine 300. The first thing you should do when you got your coordinate plane is label it in degrees. If you're not sure, well, you probably should be sure on degrees, but if you weren't sure, you do have these graphed in your notes, and use those. All right, so here are the degree measures as we go around the coordinate plane. All right, we want 300 degrees. So 300 degrees is going to be, of course, greater than 270, but not as large as 360. We haven't made it all the way around the circle. All right, so that's going to be here in the 4th quadrant. There we go. And in this quadrant, the x is positive and the y is negative. Something important to note there. All right, so this, right, is our 300 degree angle, and then we create a triangle out of that by going straight to the x-axis. It's going to be perpendicular to the x-axis. That's one point, right? Being able to graph the angle there, having it in the right quadrant, and then knowing which way the triangle goes. It goes, the side goes straight to the x-axis. Notice we do not touch the y-axis except at the origin, right? We have the hypotenuse touching at the origin. All right, so that's step number 1, and that is worth 1 point. Step number 2 is to know how to find your angle there. Right? And you have them all written down, your rules right there. It's a matter of following a rule. Can you read a rule? Can you follow the rule? All right? So let's go over the rule so I can make sure you can read and follow it. All right? So here we are in the 4th quadrant. Notice that together the principal angle, which is that 300 degree angle, plus the reference angle, adds up to the whole circle, 360 degrees. So that means that the reference angle equals 360 minus the principal angle. Our principal angle is the one we're given. It's 300 degrees, which means that the reference angle is 60 degrees. Right? Finding the... And you don't have to do quite that much work, right? These were notes, that's why I put in a little bit more, right? If you have reference angle equals 360 minus 300 equals 60 degrees, I'm fine with that, right? So that is our second step, is finding that reference angle. Step number 3 is labeling the sides of the triangle. All right, so if this is 60 degrees, you have this, by the way, in your notes. So this right here is in your notes, all right? And make sure you have yours labeled, not just with a and a square root of 2, right? Because hypotenuse as the square root of 2. On the 30, 60, 90, make sure you label a as 1. And so 1 times the square root of 3 is going to be square root of 3, and 2 side is an integer value. And it might not hurt to write down the measurements in radians on this as well. And so you have 6 coordinate planes, and you have the steps in your notes. You have these steps in your notes, all right? And you have the 6 coordinate planes. So this is for the first one. It is okay if you can squeeze in principal angle plus reference angle equals 360. It might help you out. If you can't squeeze in as much as you can. All right, so that we have step 1, step 2. All right, so notice we have a 60-degree angle. So now if we look back here at this triangle, what's opposite the 60-degree angle? It's the square root of 3. So opposite that 60-degree angle, you should write in the square root of 3. We know the hypotenuse is opposite the right angle, right? And what's the hypotenuse? Opposite the right angle is 2. So you should write in 2 for the hypotenuse. And our only side that's left, if we have one angle that's 60 degrees and one angle that's 90 degrees, the other angle is 30 degrees, and opposite that 30-degree angle is a 1. You should label that on your triangle. There are all the values, all right? Nobody has a reason not to be able to do this if they are following the steps. And if you have not printed out notes, then you either A, need to print those out now, or B, come get them from me. Right? And now we need to remember the signs of the quadrant. So remember I said x is positive, y is negative. There we go. All right? So we've got our quadrants marked, our triangle labeled with the correct values. All right? So labeling the triangle. That is 1 point. And your answer is worth 1 point. So if you only give me an answer, that's all you can get is 1 point. All right, and so our answer here, we were looking for sine 300. So just as a reminder, sine is opposite over hypotenuse. So that means sine 300, let's label the sides in our triangle. So opposite is always the y, so this is the opposite. Adjacent is always the x, and the hypotenuse, of course, is opposite the right angle. So sine 300 is going to be negative square root of 3 over 2. And there we have our answer. So that's where the 4 points come from, right? So this was step 3, was labeling the triangle. And this is step 1 here. You're drawing the angle and the triangle. Right? And that angle is the principal angle. Right? And the reference triangle. All right? Those are your 4 steps. There you go. 1, 2, 3, 4. All right? And we're going to do those 6 times. All right? So if you're paying attention, you got to have this mastered. All right? So, and if not, then what else can you do to master it? All right? Practice. That's what you can do. All right, so this is the first one. Let's do the other 5. I'm going to go probably a little faster. All right, so our angle this time is in radians. There's 0 radians. Pi halves. Now, it may be hard for you to figure out where the angle goes. Maybe not, because it's only 2/3. But if you have trouble thinking of the angle, 2 pi thirds is the same as 4 pi 6. Right? And 6 is a denominator that works with 3 and it works with 2. So pi halves here is the same as 3 pi 6. So notice, not big enough. It's not in the first quadrant, right? Because it's 4 pi 6. Here we have pi, which is the same as 6 pi 6. So our reference angle, we may as well put this one into. This is 3 pi halves. And then if we go over down the circle, we're 2 pi. So our our principal angle is going to be more than pi halves, but less than pi. right? So 4 pi 6, which is the same as 2 pi thirds, is in the second quadrant. All right, so there we've drawn our angle. Oh, instead of 4 pi 6, I'm going to write 2 pi thirds. I'll write it in reduced form. So here is 2 pi thirds. And then we can draw our triangle, which goes straight down to the x-axis. All right, that is number 1. There we go. We have done step number 1. Step number 2, we're going to find the reference angle. Notice that together, the reference angle and the principal angle equals 180, or excuse me, equals pi, which is the same as 180, but we're in radians, so. That means that the reference angle is equal to pi minus the principal angle. Since the principal angle is 2 pi thirds, right, we're going to subtract 2 pi thirds from pi. Pi is the same, just in case you weren't sure, as 3 pi thirds. So that means that the reference angle is pi thirds. All right, so finding that the reference angle is pi thirds is another point. I'm going to move this theta here because now it looks like pi 30ths. Pi thirds. All right, finding your reference angle, that is another point. All right, so third is finding the sides in the special right triangle. If you need to, keep going back to these triangles. All right, so let me just get rid of these things. All right, so pi thirds is the same as 60 degrees. So that means that the side measure opposite the 60-degree angle, or the pi thirds angle, is going to be the square root of 3. So now let's label it. All right, so this is the square root of 3. Is it positive? Is it negative? This is the second quadrant where x is negative and y is positive. So that is going to be a positive value. All right, so now opposite the hypotenuse, excuse me, opposite the right angle is the hypotenuse. Our hypotenuse is 2. And I'm going to keep going back to these so it sticks in your head. So our hypotenuse is 2. And the other side in the 30, 60, 90 right triangle, or the pi 6, pi thirds, pi halves, right, is opposite the 30-degree angle, and that is 1. All right? And so every time, those are your 3 sides. The one opposite the smallest angle, right? So if this is pi thirds, this one here has to be pi 6. Right? The one opposite the smallest angle is going to be the short side. Right? In this case, that short side is negative, right? Because x is negative. All right? We've labeled our triangle. This is our third point, right? And we labeled them over there. And our final step is to evaluate our the cotangent angle, or evaluate the angle for cotangent. So we want cotangent 2 pi thirds. All right, so this is x is always the adjacent, y is the opposite, and of course that's the hypotenuse. So cotangent, actually let's write the cotangent ratio. Let's just write down the ratio for cotangent in general. Cotangent is adjacent over opposite. So that means that cotangent 2 pi thirds is negative 1 divided by the square root of 3. The only thing you have to do is rationalize that. So negative square root of 3 over 3. Square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. There we go. There's our second one done. All right? These are all the steps, and this was step number 4. These are the 4 steps I'm looking for. All right? That you graphed the angle and the triangle, that you found the reference angle, that you labeled the triangle, that you found the trig ratio. All right? Those are the 4 steps. I cannot stress that enough. All right, so cosine 235. Now we're in degrees. All right, let's label our coordinate plane in degrees. So 0, 90, 180, 270. All right, oops, what happened to my 7 there? 270. All right, so $235 is more than 180 but less than 270. It is in the third quadrant. Here, both x and y are negative. All right, so let's graph our angle. All right, so we're going to go right here into the third quadrant. Right? And so that is 235 degrees. Right? And we can draw the reference triangle by heading straight to the x-axis. There we go. Right? That is step 1. Step 2, find your reference angle. All right, so notice that if we take 180, which is that much, and add the reference angle, we would get the principal angle. So the reference angle plus 180 equals the principal angle, which means that the reference angle is the principal angle minus 180. So that means our reference angle is 235 degrees minus 180. Oh, excuse me. I put 235. Well, if I want it to be a nice one to evaluate, just pretend it all along said 225, not 235. Sorry about that. Otherwise, we're going to be stuck. I accidentally put 10 too many degrees down. Either that or I couldn't read my handwriting and thought I wrote down 235 instead of 225. Anyhow, 225 minus 180 is going to give us a reference angle of 45 degrees. That is step 2. Step 3 is to label the triangle. All right, let's write down our angle in here too. So this is 45 degrees. We haven't done, that looks like 48. Let me make that look nicer. I haven't done any 45, 90s on this lesson yet. All right, so here, notice that the legs are exactly the same, right, because this is an isosceles triangle, and the hypotenuse is the square root of 2. And if you took 1 squared plus 1 squared, you'd have 2, right? 1 squared is 1, 1 squared is 1, 1 plus 1 is 2. And that would mean that you would have to take the square root to find the value of the hypotenuse. So square root of 2 is the hypotenuse. So super easy labeling of the triangle. Right, so the legs are 1, the hypotenuse is the square root of 2. Remember, x and y are both negative in the third quadrant, so you should label those with the -1 there. Of course, the x is the adjacent side, y is the opposite side, and of course this is the hypotenuse. And we want cosine 225, so cosine uses adjacent. Actually, let me write that down. So here's our last step, step 4. Cosine theta is adjacent over hypotenuse. By the way, you don't have to keep writing that each time, but I am writing that for our notes. So cosine 225 would equal the adjacent side, which is -1, over the hypotenuse, which is the square root of 2. And then we would rationalize, which makes that negative square roots of 2 over 2, right? Because the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. Right? So now we have done another one. I think this is our third one. So we have 3 left. Right? We've done sine, we've done cosine, we've done, I don't remember what the other one was. Cotangent maybe? All right, so now let's try another one. All right, so it's the same 4 steps, and each step gets you part of the credit. Cosecant pi 6. All right, so now let's label the measurements. 0, pi halves. Remember, pi halves is the same as 3 pi 6. And wow, I don't think we have to go any farther than that now, do we? But let's just label pi and 3 pi halves. And of course, if we went all the way around, this would be 2 pi. So pi 6 is going to be in the very first quadrant because it is smaller than 3 pi 6. And there, so here's our angle measure. Pi 6. And of course, we go straight to the x-axis. So since we're in the first quadrant, this is the first quadrant, where both x and y are positive. All right, in the first quadrant, here's our, so this was our step 1. We've graphed the angle and the triangle. Our step 2 is the reference angle. But we're in the first quadrant. So in the first quadrant, the reference angle equals the principal angle, which means our reference angle is pi 6. So the fact that you know you're working with pi 6 actually would get you to that point. Step 3, we want to label the triangle. All right, do you remember opposite pi 6? All right, so pi 6, that is from this triangle here. Let's go back and look at the triangle one more time. All right, so it's from this triangle here, right? Because 30 degrees is the same as pi 6, 60 degrees is the same as pi thirds, and 90 degrees is the same as pi halves. Right? So opposite 30 degrees, or pi 6, that's the short leg. That's going to be 1. The other leg is the square root of 3, and the hypotenuse is 2. If you're not sure, look at the diagram. All right, so let's label our triangle. So opposite pi 6 is 1. The other leg is the square root of 3, and the hypotenuse is 2. All right, they're both all positive, so that we're done with that. That's it. That was labeling the triangle. All right. Looking at that other knowing that just following the sides of the triangle. Right. This is the ratio of the sides. It was the very first thing we worked on. And step 4 is just to find the trig ratio. So cosecant theta, it's the reciprocal of sine. It is hypotenuse over opposite. And we should really label the triangle here in terms of opposite and adjacent and hypotenuse. X is always adjacent, y is always opposite, and opposite the right angle is the hypotenuse. So now cosecant theta is going to be 2 divided by 1. Excuse me, cosecant pi 6 is going to be 2 divided by 1, which is just 2. Right? And we have that same value, right? In another quadrant, we had gotten an answer on a problem that was 2. Right? So we can get the same values in different quadrants. They do repeat. And that's it. That's our 4 steps, right? Graph, find the reference angle, label the triangle sides from the 30, 60, 90 or 45, 45, 90 triangle, and then evaluate. Right? And it helps to label which is opposite, which is adjacent, which is hypotenuse. I've got 2 more. This one is secant 690. All right, so let's write down the measurements. This is 0, this is 90, we're dealing with degrees in this one. This is 180, this is 270, and this is 360. So let's graph our angle. Our angle goes all the way around the circle, that's 360. And then we got how much more, right? We got another 330 degrees. So we're going to go around the circle. We're going to keep on going. All right, now what if you're not sure where that's going to go? All right, since step 1 on this one, along with graphing, is to find a coterminal angle. So if your angle if your principal angle is more than 360, or 2 pi, find a coterminal angle. And I did this one in the last video. So the coterminal angle is going to be your principal angle, the angle that you're given, which in this case is 690, minus 360. And you can just keep on subtracting 360s all you want. So 690 minus 360 gives us 330 degrees. Right, so our angle is going to stop right here. This is 690. This much of our angle, that much of our angle is 330 degrees. Now you may remember how to find the reference angle. Our triangle goes from the terminal side of the angle straight back to the x-axis. So there's our reference triangle. Now we need theta, we need our reference angle there, and we can find the reference angle using the coterminal angle, because it would be nicer to work with an angle that is less than 360 degrees, because we'd have to get there anyhow. Right? So no matter what, we would have to change that 690 and make that a coterminal angle anyway that was less than 360 degrees so that we could find our reference angle. So this one had a little bit larger, step 1, because we had to find the coterminal angle in addition to graphing. Step 2 is the reference angle. We're in the 4th quadrant, so the reference angle is equal to 360 degrees minus the principal angle, which is 330. So that means the reference angle is 30 degrees. And if you remember, we did a triangle like this one. Right? It's just this time I gave you 690, right? And you had to find that coterminal angle. So that means your reference angle is 30 degrees. All right? And if you need help, you can always go back to this. The triangle's back here. All right, so oops, too far. Opposite the 30-degree angle is 1. Right, the other leg is the square root of 3, and the hypotenuse is 2. But we are in the 4th quadrant, so we've got to pay attention to the signs. Right? So here, the x is positive, but the y is negative. So this is going to be a negative 1. Actually, let me change colors here. I'm trying to color code. So when we label the triangle, which is our step 3, right, opposite the 30-degree angle is 1. And it's going to be negative because y is negative. Along the x-axis is the other leg of the triangle, which is the square root of 3, and the hypotenuse is 2. All right, and our final step here is to evaluate. We want to find secant 690 as a reminder. Secant is the reciprocal of cosine. It's hypotenuse over adjacent. So that means that secant 690 is 2 divided by the square root of 3, and then we'll rationalize that. So that gives us 2 square roots of 3 divided by 3. And there we go. Right, so we have found another one. And we have one more problem left. Remember, this video was a little longer, but I went over all these problems again. And so just watch it and do it. If you need to, do it with me. Right, so just rewind me and watch me again on the student-paced version, and you can have me help you with your homework. And just go to do the same steps I'm doing, but with your problem. Right, and this is our last one, tangent 13 pi fourths. Right, so here, let's label the triangle. We have 0. Pi halves is the same as 2 pi fourths. And when we have pi, which is the same as 4 pi fourths, so notice we're still larger than 13 pi fourths is larger than 4 pi fourths. Then we have 3 pi halves, which is the same as 6 pi fourths. And then we have 2 pi. So notice, which is the same as 8 pi fourths. So notice we're still too big. All right, so we're going to go around the circle plus more. All right, let's figure out how much more by finding a coterminal angle. All right, so here when we're graphing our angle, it goes all the way around the circle. And now let's figure out how much more it goes. All right, so step one here, we're going to find a coterminal angle. And that's going to be equal to our principal angle, our given angle here, which is 13 pi fourths, minus 2 pi, right, because we are too big. 2 pi is the same as 8 pi fourths, so that would be 5 pi fourths. All right, so we want to graph 5 pi fourths. So from here, right, this would be another 4 pi fourths, and then 5 pi fourths. So 13 pi fourths goes all the way around the circle, and then another 5 pi fourths. And to draw a reference angle, a reference triangle, we head straight to the x-axis. There's our reference triangle. All right, so that was step one there. Getting our coterminal angle and then graphing our angle. Step two is the principal angle, the reference angle. We are in the third quadrant. The reference angle equals the principal angle minus, in this case, since we're dealing in radians, minus pi. So that would be the 5 pi fourths, right? That's our coterminal angle now. Minus pi, which is the same as 4 pi fourths, which is going to give us pi fourths. So that was step two, knowing that your reference angle is pi fourths. Now we can label the triangle. Remember, right? So pi fourths is the same as 45 degrees. So this is a 45, 45, 90. The legs are 1. The hypotenuse is the square root of 2. Any day now. We'll get back to it. I think it's the next one. Yes. So this would be 1 and 1 and the square root of 2. But remember, this is the third quadrant where x is negative and y is negative. So these are both negative. And then our final step is to evaluate for tangent. So tangent theta is opposite over adjacent. That means that tangent 13 pi fourths, the opposite side is y. The adjacent side is x, so this is negative 1 divided by negative 1, which is just 1, right? And we've done it. So we did a problem similar to this on the last lesson. If you go around the circle but end up in the same spot, right, it's still going to be the same values when you evaluate. So this was a little bit long of a video. Maybe I'll break it up into 2 parts. But thanks for watching. And hopefully now you are feeling more confident with evaluating for trig ratios, evaluating for angles on the coordinate plane. Right? So thanks for watching, and bye for now.